So then today, we're going to do some things that are review with graphing before, but we're also going to see how, like I said, some of the things that we've been doing lately are going to kind of blend in. So for this top part should basically be review. We're going to graph the function, we're going to identify the vertex, the axis of symmetry, and the direction that it opens. Now, a couple of those things we should be able to do fairly quickly. I would say for sure, the quickest one should be which way is this sucker going to open before I even graph it. I go, what? How do I tell which direction a quadratic is going to open? Right, my a value is going to be whether it's negative or positive. And you're like, well, I don't necessarily see a number here, then we assume it's going to be 1. So here, since it would be positive, my a value would be 1. So I know right away before I even graph it that this is going to be going upward. So that's a good hint to know in case I graph it and something goes screwy and it's going down. Next thing that should be fairly easy to come up with here should be the vertex, since these are all in vertex form. What's my vertex going to be? 3, negative 1. Because again, when I'm doing these, the formula or the equation that I'm normally looking at is x minus h squared plus k. So it's the opposite of what my actual h value would be. So the opposite of negative 3 is 3. And then we keep our k value. Okay, so far so good. What about my axis of symmetry? Okay, good. It's x equals and whatever the x value of my vertex is. But I have to have the x equals. If I just put 3, that could be a point, it could just be a number, who knows? I want people to know it's going to be a vertical line. So it's x equals 3. And then when it comes to actually graphing it, I don't care which option you go with. And again, it might be different depending on what tools you have and what's available to you. But at least what I would be looking at, possibly, I can punch it into the calculator if I wanted to. And then instead of necessarily going to the graph part, if I get my vertex in the middle, I get to see the symmetry. And fairly quickly, I can get myself some more points. Now I'm going to show you something here in a minute that might even speed this up more, and I might not need the calculator at all. At least for the types of problems that we're going to be working with here. So I'll get my parabola through there and I'm good to go. Get this back out of the way. But again, this is more just kind of warm up, getting us ready and raring to go here. Let's see. What direction are we going to be going in number 2? Up or down for numero dos? Up. Because again, my a value is 1. I don't see anything in front. So this guy's up. What's my vertex going to be? Okay, negative 1, 2. Which means my axis of symmetry would be at x equals negative 1. And here's where I'll talk for a second about how this can quicken up for you. We know that when we graph our base graph, y equals x squared, basically those first 3 points make a little triangle. Because it's basically just like up 1 and over 1. It's almost like slope. Whenever you don't have an a value, or even if it's negative, okay, if it's just 1, what I find out is, I'll risk it, but then I'll show you on the calculator too. If you just go up and over 1, and you do it going each direction with these, I can actually get a pretty decent idea of what my graph is going to look like. Now, is that going to be the most accurate? No, it's not better than doing 5 points. But if you're looking for that initial set of points to be able to use to maybe make things go a little bit quicker for you, that's an option. Because when I bring this one up and get my vertex value in the middle, I notice at 0 and at negative 2, my y value is 3. It's just basically going up 1 and over 1. And that's the 2 points I made here originally. And you may even be able to start registering some patterns from that even, because then you're like, well, wait a minute, negative 3, 6, and 1, 6. let's check this out. My first one, up 1 and over 1, okay. And then my next one went up 3 and over 1. Let's see if that happens again. Up and over 1, up 3 and over 1. Oh, okay, there is a pattern to this. So maybe I don't need the calculator to get me my other points to make the parabola. Nothing wrong if I do use it. But again, if we can find a pattern that makes it go a little bit quicker, well, that's even all the better. Especially if we don't have calculators available all the time. All right, last one to throw a twist in on. What direction are we going this time? Down, because we've got a negative a value. What about my vertex? Okay, 4, negative 4. Even with that negative out front, that doesn't change the format. The opposite of h, and then plus k. So 4, negative 4. And then again, my axis of symmetry always goes with my x value of my vertex. So, now again, I could go to the calculator. I could even plug numbers into this if I wanted to. But again, I like to try and make little shortcuts where I can. So since this is opening down, go down and over, and then like we did over here where we went up 3 and over 1, I could just go down 3 and over 1. And again, if you're nervous that you may forget the pattern or you may try to apply it somewhere else, that's okay. We can always come back to here. Let the calculator help us out. And go to the chart. Now again, my center's at 4 this time. Gotta come down a bit. And I start checking this out. Oops, I didn't put my negative in. I was wondering what was going on. That's better. So I notice for 3 and for 5, it goes down to negative 5, just like I did here. And for 2 and for 6, it goes down to negative 8. So again, using the pattern is a legitimate way to graph when you just have a coefficient of 1 on those. Patterns and math go hand in hand. However, and we see again our vertex form down here. However, sometimes we'll get something in its regular form. We'll be asked to put it into vertex form. Because vertex form, of course, is an easier way to find the vertex and some of those other issues. So as we come down a little bit further, when it says for us to write it in vertex form, now I start to look at this for a minute, and I'm like, well, but I don't see anything where there'd be a shift. I mean, if I looked at this, and I looked at this, and I said, okay, well, what if I tried to complete the square, sort of like what we were doing before to get it into vertex form? Would that be something that would help me? Well, maybe. That might be something. Let's see here. What happens if we complete the square on these? Well, let's think about it this way for a second. Normally, we'd go ahead and we would attempt to isolate our x's, but there's no x term here. So just for now, just to see it on this first one, I'm going to pretend that that 0x is there. I'm actually going to write it in. Well, then you're like, well, wait a minute. Isn't the rule b divided by 2? Wait a minute, if I do 0 divided by 2, that's still 0. And if I square it, it's still 0. So I'm just going to add 0 to both sides? Why would I want to do that? You're not going to want to long term, but I want you to see what happens when we actually do it this way, just on one. So you're like, okay, I'll go along with this. So I'm going to add 0 in those two slots because this is how we got back to the vertex form. But you're like, okay, but that'd be the end normally. Normally I'd subtract this number over. Well, there's no number there. You're right. Normally, I'd put this into its binomial form, except I can't because that's 0. So this just ends up being 2x squared and plus 4. Wait a minute, I got back to the same thing. Okay. This, if you're not going to have an x term in here, So either of these first two, it's already in vertex form. If there's an x there, we can complete the square, but that's the only way we can. But I can still get the information I need out of this. Because I look and I go, okay, so my vertex normally would be this x plus or minus number that's here, like it is here, but I don't see one. So what value am I going to use? 0. But my k value is just the plus number on the end, and that's still there. So my vertex is at 0, 4. And as we've talked about before on some of the other ones, my a value is 2, it's positive. So this quadratic is going to be opening upward. And my axis of symmetry is going to be at 0. But again, if you don't have an x term, there isn't going to be any change with these. So my vertex form will just be what it is already. So that's also going to be true on number 13. But let's see here. What's my vertex going to be on number 13? Yeah, 0, because again, without that x term, it'd just be x plus 0 basically here. So 0, 5. I notice my a value is negative. So this guy would be opening down if we were to graph it. And my axis of symmetry still is going to be at my x value. It's still going to be at 0. And that's it. She's like, shoot, give me no x's every time. Don't even have to do anything. Well, that's about to change. Because now I do have an x value. So remember, when we're doing these, I'm going to put the blanks in here. I'm going to isolate my x terms. And I'm going to do my b divided by 2 squared to get that blank value. So just like we have before, my b value is 4. Divided by 2 would be 2 squared, which is 4. That's what's going to go in each one of my blanks. Because now I can turn that perfect square trinomial into its binomial form by, remember, taking my b divided by 2 number. Or I could factor this. But my b divided by 2 number is 2. And now to get it into vertex form, I just have to move that 4 to the other side of my equation. And this is a little more of a classic one, like the ones that we were looking at up above. But again, it's because I have that x term. If I didn't, that'd be a different issue. So my vertex would be at -2, -4. Because again, the opposite of h. Then I keep my k. Since it's a positive a value, this guy would be opening up. And my axis of symmetry, again, even in this form, stays with the x value of my vertex. And the only other twist I can throw at you on this is you're like, well, is it going to matter if there's a value on the end? Not really. Because all I'm going to do is just like when we were doing it with completing the square before, is I'm going to go ahead, I'm going to put that blank in, but the -4 is going to, oops, -4 is going to be right off the screen. -4 is going to be outside of that because we'll take care of that at the end. Now again, this one's a little nastier, but we've found out ways to get around this before. My b value is 3. Well, if I do 3 over 2, I get a decimal. I don't want the decimals, because when I go to do my radical, it's going to make this complicated. So 3 over 2, I'm going to go ahead and square it, and just remember, just square each of the numbers. 3 squared is 9, 2 squared is 4. So that's going to be my number that gets put in. And then I'm just going to go back. I'm going to get it into my form first, then I'll get rid of that 9/4. And remember, keep this simple. You don't have to factor this to get it into its binomial form. Just steal the b divided by 2 number. So if stuff looks nasty, take a couple of the shortcuts. And then my last step is going to be to minus that 9/4 over. So when I minus that over, again, if this isn't a strength for you, you always have a backup plan. So you could always do -4 minus 9/4. Again, otherwise you just need a common denominator. Do not do the decimal. And that craziness actually would be your vertex. Now, I know how some of you are uncomfortable working with some of these when you're like, I'm really not sure that's the answer. I mean, how would you know this? I don't know. Let me tell you a couple things on what you could do to double check after we answer a couple of other questions. My a value is positive, so this guy's going up. My axis of symmetry still works the same way. But how do I know for sure that vertex is right? Let me tell you. If I get my squared on there in the correct place, if I take either this form or even my original form of my equation, and I go ahead and I type that in, and I graph it, and I go, okay, my vertex is going to be down here. It's a minimum. So I'm actually going to find the vertex on this. I'm going to find the minimum. Whoops, not the maximum, the minimum. And just like before, my little cursor guy, I want him somewhere to the left of my vertex. Lock him in there. Again, somewhere over here to the right of my vertex is good. And then I'm going to come back down here. And it says my x value is at basically -1.5, -3/2, -1.5, and -6.25. -6.25. Okay, I did it right. So you can double check. There are ways to be able to figure that out and go and get your information if you want to see if something just doesn't seem right to you for some reason. Sometimes even just graphing it and getting a general idea of where the vertex is can really be helpful in figuring out if your answer makes sense. So finally, okay, write each of these in quadratic, write each quadratic function in vertex form. Give the coordinates of the vertex, the axis of symmetry, and the direction of the opening, just like we have been. And then graph it. Okay. So here, now I'm going to look through this and I'm going to say, okay, now here's where life starts to change. You notice the main difference between what we're doing here and what we did in the section up above is now you have a coefficient in front. This is going to change things a little bit. So just kind of stay with me on this. Okay, I'm going to turn my g of x into a y. Okay, I just put that in there because sometimes they're written this way, and I wanted you to get used to seeing that. Okay, so I'm going to have y plus my blank. We're not getting rid of the blanks. Here's where things get different. When I section off my x's this time, I've got to have this just be x squared. So whatever coefficient's in front of my x squared is going to get pulled out front. Okay, so 2 times x squared would be 2x squared. 2 times 6x would be 12x. And then put in your blank. And your plus 13. So it's not changing a lot. I just have to pull that coefficient out. Now this is the part that gets a little interesting. So stick with me here. We're still doing b divided by 2. So that would be, whoa, divided by 2, Harty. That would be 3. and square it. Okay? This one's 9. Now get ready to be amazed. That 9, since I pulled the 2 out here, 2 times 9 is 18. That's what has to go on the other side. So now, instead of just taking the same number and putting it in both places, whatever this number is that I pulled out, I have to multiply it by that before I add it in. Because then I can still make it look just like it did before. So this will be x, my b divided by 2 is 3. But now I've got to take that positive 18 and subtract it over. So my blank will be gone. I left a little too much room in there. So 13 minus 18 will be minus 5. And that's going to be my equation for this particular expression in vertex form. So once I get that, now I can get all of my other info. I can get my vertex, -3, -5. This is not one where I can just do the up one over one, because now I've got a coefficient. My axis of symmetry is -3. Still stealing it from here. Positive a value. We're going up. And this is just me. Again, you could plug numbers individually into that. It works. I'm not going to tell you it doesn't. So it's not one of those, if you don't have a graphing calculator, you physically can't do this. You could. But, again, I'd plug it in its original form if I was going to put it in the calculator. Even if I was going to plug numbers in, I'd plug it in its original form possibly here. Now let's see if our vertex works out here. Okay, my vertex is in the middle of my chart. I see symmetry. Woo, got my vertex right. And that's why I like typing it in this way, because now you're really going to get to see from the original if this worked well or not. And now I can get my other points here. So -2, -3. You're like, hey, instead of up 1 and over 1, it's up 2 and over 1. I wonder if those are related. Maybe. -5, 3, 0, whoops, -1, 3. And you start to look and you're like, hey, in the other one for my second set of dots, it was up 3 and over 1. Wait a minute, 1, 2, 3, 4, 5, 6 and over 1. It doubled. Hey, it's that 2 in front. Again, if you can see the pattern that develops, like we did up above, you can save yourself a little bit of time when it comes to graphing. But if not, it really doesn't take that long to put it into the calculator and find it that way. I want to check one more of these out. So let's try out 19 here and kind of keep that idea going of what we're up to. All right, y in a blank. I'm going to pull out the -3 because, again, I want my x squared value to be positive. Now we're like, okay, so x squared, -3 times -2x would distribute back to positive 6x. Watch your signs. Plus my blank, and then the -9's at the end. So I do my thing. Okay? Now remember, when you're doing this, your b value, be careful, your b value is now what's been factored. So it's this -2 over 2 would be -1. Use the parentheses and square it. It's always going to come out positive. But then before you go too quick and stick a 1 over here, what number is going to go in my y blank? -3. This times whatever I had for my x blank. And then the only thing I've got left to do is get my perfect squared trinomial into its binomial form, which again is just taking the x and my b divided by 2 number, or I could factor this. And then since we've got a y minus 3, same thing here, I'm going to add that over, which would give me a negative 6, and I'm into vertex form. And I can get my vertex, which is the key, because then it makes it easy if I'm looking in the table of the calculator or any other thing. My axis is at x equals 1, my x value of my vertex. And since I have a negative a value, I know this guy is going to be opening downward. Now again, I can try to get fancy and play the pattern, or I can say, well, I am content since I currently have access to a calculator. I'm just going to type my original equation in. I'm going to go to my table, and again, I need my vertex in the middle. If it's in the middle, I should see some symmetry, and I do. It looks like I'm only getting 3 points this time, too. So 2, negative 9, 0, negative 9. I'm really skinny. So that's the biggest thing with these. A little different from regular completing the square when we got to pull that number out and kind of work it that way. But otherwise, nothing too bad working here. So your task is not very far away. And if you find you're a little too cramped for space here and want to work on another piece of paper, that's completely legit. But again, this is going to be our last assignment for homework check 8. It'll be the 4th one. I'll have this listed on the backboard here in a bit because it looks like I haven't done that yet. You get a couple of graphs, but for the most part what you're doing is you're doing a lot of completing the square practice just to get it into a form that's a little bit easier to work with. And then we will just kind of keep plugging along here a little bit tomorrow.